Hello everyone. In this video we'll learn how to solve quadratic trigonometric equations in a form ax squared plus bx plus c equal to 0. So by looking at this function here, the midterm is cosine theta, so I'm going to say let u equal cosine theta. So I'm going to get 2u squared minus u, and I will move 1 equal to 0, and then I can factor it. So u equal -1/2 or u equal 1. Now I'm not calculating u, I'm calculating cosine theta. Now I'm going to ask myself when I'm going to take cosine inverse on both sides. Let's do it here. So I'm going to say cosine theta equal -1/2. Theta equal cosine inverse of -1/2, which is equal to pi over 3. The other side, cosine theta equal 1. Now, by asking ourselves what is when cosine is negative, we're going to say, oh, cosine is negative in quadrants 2 and 3. So an angle in a quadrant 2 basically is the same one, 2 pi over 3. That's an angle in a quadrant 2. What about an angle in a quadrant 3? Well, I need to know the reference angle here. And the reference angle will be the same as this one. So our reference angle is going to be pi minus 2 pi over 3, which is equal pi over 3. Now by going here, theta will be equal pi plus the reference angle, which is equal 4 pi over 3. So now so far my solution includes 2 pi over 3, pi over 3, and then let's see what we are going to get from this side here. Cosine theta equal to 1. Now 1 basically is the maximum value in cosine. The range is between -1 and 1. So this is a quadrantal angle. A quadrantal angle means it's not in any of the quadrants, basically on the axis. So I will recall the shape of the parent function from 0 to 2 pi. So where's the 1? 1 is here. So this is the first angle, this is the second angle. This angle is 0, and this one is 2 pi. So cosine 0 is 1, cosine 2 pi is 1. So these are my other angles. And here we go. Now what about this question here? 3 times 1 minus sine x equal cosine square x. First of all, I'm going to expand. 3 minus 3 sine theta equal cosine square theta. Now moving everything to one side, I could say cosine square theta plus 3 sine theta minus 3 equal to 0. Now what happened? I have cosine and I have sine. Well, there is a very important trigonometric identity says cosine square x plus sine square x equal to 1. That's a very important identity. So what is cosine square? If I move this one there, cosine square x equal 1 minus sine squared x. So I'm going to use this to substitute cosine square by. So this is a very important formula. So cosine square x equal to 1 minus sine squared x, and then I can put the rest. Oh, okay, I'm not going to say x, I'm going to say theta, sorry. Collect 1 and -3. I'm going to rid out of the negative in the leading coefficient by multiplying everything by negative. And now this is a quadratic function. I can say u equal sine theta. Let u equal sine theta. and then you can factor it. So when you factor, that will be u minus 2, u minus 1 equal to 0. So it's either u equal 2 or u equal 1. So you can say sine, instead of u, we'll use sine. It's either sine theta equal 2 or sine theta equal to 1. Well, sine theta equal to 2, remember, the range of the sine is from -1 to 1. It will never go to 2. It cannot go greater than 1 or less than -1. Also, if you try sine inverse, that's an error. Now, what about this side? Well, this is 1, then this is a quadrantal angle, 1, 0, -1. So we are better to draw the parent function of the sine in one period. I want 1, so it's going to be this angle here. That's basically pi over 2. So my solution set is only one angle, which is pi over 2. Now, let's move on to the next question. 6 cosine square x minus sine x minus 4 equal to 0. So now I'm going to substitute cosine square by 1 minus sine squared theta, same as the previous question. I'm going to expand. And then collect the 6 and -4. I like to multiply everything by -3 out of the negative sign and the leading coefficient. And now I could factor, so it's going to be, I'm going to use substitution. I will substitute u by sine theta. It's going to be 6u squared plus u minus 2 equal to 0. That will make it 2u minus 1 and 3u plus 2. So it's either u equal 1/2 or u equal -2/3. So instead of u, we have sine. So I'm going to say sine theta equal 1/2 or sine theta and -2/3. Now I can take sine inverse, which is equal pi over 6. Here I can take also sine inverse, and that's going to be equal, basically it's a decimal, -0.73 radian. Now I need to ask myself here, when sine is positive in quadrant 1 and 2. In quadrant 1, then theta is pi over 6, because pi over 6 is 30 degrees. And here, this is going to be a reference angle, which is still pi over 6, so theta equal pi minus pi over 6, and that's going to be 5 pi over 6. Now here, I need to ask myself when sine is negative, and sine is negative in 2 quadrants. In quadrant 3 and 4. And if it is in quadrant 3, I need this reference angle and this reference angle. Well, if you try 0.73, this is already without the negative sign. This is a acute angle. It's less than pi over 2. Again, pi over 2 here, it means 3.14 divided by 2, which is 1.57. So 0.73, forget about the sign, is still less than 1.57, which is pi over 2. So it's an acute angle. Then we can say here theta will be equal to pi plus 0.73. Here theta will be equal to 2 pi minus 0.73. Answer here will be equal to 3.87 radian, and here 5.55 radian. So my solution said pi over 6, 5 pi over 6, 3.87 radian, and 5.55 radian. Okay. Now in this question, I need to find sine 2 theta plus sine theta equals 0. Now sine 2 theta, there is a rule. It says sine 2 theta double angle equal to sine theta cosine theta. That's a formula. So I'm going to substitute sine 2 theta by this. Then plus sine theta equal to 0. Then I'm going to take sine theta as a common factor. Now I do have either sine theta equal to 0 or 2 cosine theta plus 1 equal to 0, then cosine theta equal negative 1/2. Now on this side here, this is a quadrantal angle because of 0. So quadrantal angle. When you have a quadrantal angle, better to draw the function. Where is 0? 0 is here, 1, 2, 3. So I have 3 angles that can give me the sine of them equal to 0, which is 0 and 180 pi and 2 pi. So these are my 3 solutions from this side. From the other side, I'm going to take a cosine inverse, and this is going to be equal to pi over 3. Then I need to ask myself when cosine is negative. Well, cosine is negative in quadrant 2 and 3. In quadrant 2, this is an angle in quadrant 2, it's 120. So theta equal to pi over 3. In quadrant 3, it's pi plus reference angle. I need to tell what is the reference angle, which is this angle here. Well, it's going to be pi minus 2 pi over 3, which is equal pi over 3. So you are going to go here and add pi over 3, which is equal to 4 pi over 3. So I do have 5 solutions. 0, pi, 2 pi, 2 pi over 3, and 4 pi over 3. Pi over 3 is not a solution, it's only a reference angle. Last question here. Cosine 2 theta minus sine theta equal to 0. There is again a rule for the cosine double angle. It's equal to 1 minus 2 sine square theta. So I can substitute cosine 2 theta by 1 minus 2 sine square theta, and then organize the equation. I prefer to multiply by negative. Now let u equal sine theta. So 2u squared plus u minus 1 equal to 0. Now you can factor. So it's going to be 2u minus 1 and u plus 1 equal to 0. So it's either u equal 1/2 or u equal negative 1. Now we return u into sine. So you're going to say either sine theta equal 1/2 or sine theta equal negative 1. I'm going to start with this side because this is a quadrantal angle. Negative 1 is this here. That's a negative 1. So that's one angle, which is going to be 270 because this is 0, pi over 2, 90, pi, which is 180, then 2 pi over 3, 270, and then 2 pi. So, so now I have one solution, which is 3 pi over 2, 270. Now on this side, I'm going to take as inverse. Then I need to ask myself when sine isn't positive, quadrant 1 and 2. Quadrant 1, I already got an angle in quadrant 1, and it's also a reference angle, so it's going to be this side here. So theta equal pi minus pi over 6, which is equal 5 pi over 6. So my solution set, pi over 2. That's everything, guys, in this lesson. Please let me know if you have any question, and see you next time. Bye bye.